In this screencast, I'm going to show you how you can determine the oxidation state for any element, either in a compound or an ion, by looking at the charges of the other elements in the compound. So the example we're going to do is we're going to figure out what the charge is on the phosphorus in Ca3PO4 in parentheses 2. So the first step is to identify the charges on the other elements. So for calcium, we know that its charge is +2. And for oxygen, we know its charge is -2. All right. We will use that information, how many of the elements are present, to figure out then what our phosphorus has a charge of. The second step is to figure out the charge on the whole compound as it's written. In this case, we have nothing, so that is a 0 charge. Sometimes you might have an ion that has its own charge. So the overall charge on this NH4 down here is a +1. You're going to have to use whatever charge they give you, and you need to know what the end result of combining all the positives and negatives gives you. We're going to do some math. We have our calcium. There are 3 of them, and they're each +2. That gets me a +6. I have my oxygen. There are 8 of them, the 4 times 2, and they're -2. That gets me a -16. And I'm finding phosphorus. The whole thing is going to equal 0. All right, so, and I have 2 phosphorus. I can do some simple math to cancel some things out. I'm going to take my +6 and -6, and that gets me -10. So I need to add something here plus this -10 to get my 0. So it's a +10. And now I'm going to take and I'm going to divide my +10 by the 2 to figure out my value. So that means that 5 would make that work, because 2 times 5 gets me 10. And then my +6, my -6, and my +10 gets me 0 overall. So the answer for what is the charge on phosphorus in this compound, the phosphorus has a +5 charge. It's just a matter of taking and breaking it down into multiple steps and doing the math. Replay this if you need to see it again.